and so on. Those objects have the formula to find. But in our real life, we have some weird object which is doesn't have any formula to figure it out. So calculus enable us to find the volumes of these weird shapes of the weird object, just like the feeling bottom image. Um, and why do I want to talk about this? And I'm going to show you the concept through some of the mathematical software developed back in the time when I was learning calculus. We didn't have a lot of technology advanced to show us um, in the lectures, or like we can see some pictures in the textbook, but sometimes we don't. I remember back on those days, I did not even like seen those pictures, those image, and so it make our learning is a lot harder. um, but with the new technology now, I hope you can enjoy what I show you today. So I will share with you the picture, the image generated from the computer software online, and I also will show you my presentation points in this video. So let's share with me the screen here. I'm going to share screen with you and show you the ideas of what is the volume of solid revolution mean. I don't want to get into the lectures and explain to you on the like the complicated details explanation, and on the computation we try to avoid in math. So I would like to present this to show you the connection, and you will be able to visualize the image and understand and reconnect when we explain about the lesson. I think it's important. So let me share with you. So I'm going to share with you the screen about this. So this is my PowerPoint presentation, but first let me show you what does it mean when we're talking about the volumes of solid revolution. Okay, so bear with me. I'm going to show you the image here. Okay, so you will see that on the left, right? This picture look like what we have learned so far. On the left, we have a curve with the region under the curve. But on the right-hand side now, it generates the volume of solid of region here to create the volume of an object with the weird shapes I was talking about. So let me show you one more time. You see that it have a three-dimensional, like the y and the x-axis and the z-axis that enable the generate the volume revolving around the axis. Let's see it one more time. Okay, so make the observation carefully. You see this? It generate and make it become the object, solid object revolving around the axis. Now let me show you another one. So you see this is another one, and you see that it generates and make this revolving around it. So we have this the shape that we want to generate. And this is another one, I think, that is method. So you see that this is the curve, right? And under this curve is, we're talking about 2 dimension, there will be the area under the curve. But now we're talking about 3 dimensions. So we have the solid object here with the weird shapes. And under this curve, if without the technique of the calculus method of integration, we have no way to find out the volume of this object. So this is the idea, and I think that is enough for now. I'm going to show you, so you get at least some visualization, right? Before we learn this topic. So let's go into my slides PowerPoint. And I'm going to click on the presented. I don't know if you are able to, I think that I have clicked on new share. Okay. Okay, so here, this is my PowerPoint presentation. So this is slide 1, is a topic. Now, I'm going to give you some idea of the definition of volumes of solid revolutions. So generally speaking, volumes of solids of revolution is the use of definite intervals to find the volume of a solid, which is obtained by revolving a plane region about the x-axis or y-axis. There are 2 methods can be used, known as a disk method or shelf method. So in this introduction, I show you, show you the concept, the definition of it. So volume of solid revolution are the ways to find the volumes of objects by revolving the plane region about the x-axis or the y-axis. Basically, that is mean, right? Okay, so let's go to the next slide. Okay, let me see. Okay, so the next line here, oh, it go too fast. Okay, let me, so it go too fast, let me. So here in this method, I talk about, imagine a cucumber is sliced into many cross-sectional areas. Each have a shape of a disc. You will explore more and more this lesson in my teaching videos. Now the next one, we're talking about the shell method. So you see the shell method here, I stated, imagine a volume of an onion. If we take off on the shells and stack these shells together to form an onion, this technique refers to the shell method to find the volumes of any solid objects. All of this lesson will be explained in details in my teaching videos and will incorporate with this slides presentation for this fascinating topic. So before I move on to show you the next one, and let me show you a new share. I think each time I have to. Yeah, so on my screen, you see that there's the lesson from the internet, right? um, it show us the image, very nice image, and I wish that I seen this before when I was learning. So here we have a curve here, right? And underneath this curve, we have a region underneath it. Now we're talking about two-dimensional. So you have learned with me about the iteration in two dimension already. Now we go to the third dimension, which is the next picture, the next image. So this curve will allow us to generate the volume of solid here. That's why they call the volumes of solid revolution, because the revolution mean we generate it along around the x-axis. In this case, we generate along the x-axis, right? And in other case, you will see we generate along the y-axis. For example, look at this curve. So this is a curve, right? And there's a region under this curve along the y-axis. So you look at the arrow on the top. See this arrow? It shows us generate revolving around the y-axis. And finally, when we revolving enough, we have the volumes of these weird objects. Okay, so that's the second image I want to show you. Now, underneath this image, you see there is a formula here, right? And they explain here, I will explain to you in the next lesson about this formula and how we iterate, how we perform our iteration. I want to show you another one here. You see these two curves here? So the first on the top and the second, that is the two curves, and it produce a weird object like this. If we be able to generate it and make it revolving around the x-axis, we get the third image here, which is this shape. And to do this, we can use this method, or we can use the shell method. And we were talking about both of these methods in a few next lesson. I will explain this detail on the boards to you. And before I ended the sharing here, I would like to show you some of my lesson plan about this fascinating topic. So here is another one, right? The image is so clear here. You can see this curve, and underneath this region, we can revolving around. I think this one is around the x-axis again. Let's see, x-axis or y-axis? I think it's x-axis. So you'll be able to find out the volume of this solid shape here. So I think this is enough for now. And I will show you my lesson plan on the interesting lesson. Okay. So here is what I show you about the cucumber, right? I will talk about this, but let me stop sharing. Okay, so if you look at my lesson plan here, I draw the cucumber, right? The shape of cucumber. And by this method, we will cut this cucumber into a very small cross-sectional area like a dish, right? Like a circle, like a dish. And then we iterate it to find the total of them. We get the shape of the cucumber here. So that's the idea. And on the back, you can see that I try to draw the picture to show you we generate using this method and revolving the x-axis to produce this shape. Now, in another one, I show you And these are the on the formula from my lesson plan. And um, there is another one. So if I try to draw, right? I try to draw the image of how we slide this into cross section under this curve so that we can find the volume of the shape. Now, in here as well, I try to draw it in a 3 dimension, right? So it's supposed to be, this is 2 dimension, but if you look through the rectangular shape I draw here, look like I slide it, become so many planes, right? It like 3 dimensional, and that is, I try my best to draw how we slide this shape, um, and to find the volume of the object. Okay, so in another drawing, this is the one you see familiar with. So this is on my lesson plan with my hand written and the drawing, right? So if you register to my course, you will have access with all of these lesson plans. And I draw a 3 dimensional, like look very much like the shape you have seen on the board I show you. And in another picture, so this is a good picture. You can see that this is the shell method. When we try to generate it using the shell method to get the image. And here is another picture. It show. So this is another my lesson plan, right? And I make it look very clear to you that this is the shape after we generated revolving around the y-axis. Finally, you can find the volume of this object. We can form it as well, right? So this is generate a revolving the region of the blend region around the y-axis. And on my notes here, we explain very clear the way how we find it. So now we'll show you, this is the cosine function and the sine function. So if these function across each other, you see that this have a little shape here, and on the right hand side, we see that how we generated and we produce this shape here, right? So that is very clear the way I draw it, right? And it's interesting. I found this topic is fascinating, right? So I hope that you will enjoy it. Now, despite the complex formula and thing, but if we understand the concept, we know that when we're supposed to slide and across the sectional area, sometimes it might be a rectangle cross-sectional, sometimes might be a disc, and depend on the function, right? So you can see that in this way, we have slide this region by so many cross-sectional area, and the cross-sectional area here is the triangle. And we'll be able to generate it revolving to get the shape of the object. So this is just another way of slide the object through by this shape of triangular shape, triangle shapes here. And okay, so I think that's very much about on my lesson plan on the notes, and we'll explain step by step how you can do it. And I hope that this topic If you understand it, you will find it very fascinating topic and very interesting, right? Without the calculus, I mean, like, is there no easy way to find these volumes? And we have so many of these objects in our life without the formula to of geometric formula to find it. So calculus find the way. It's the concept. The idea is a complex concept, but um, it's like the conceptual thinking. And if we understand these conceptual thinking and the way we find it, right? We use the iteration method, we use the derivative, and we use the antiderivative and derivatives solve many problems. Now we get into how to find the volumes of the volume solid revolution. So that's all about my presentation today. In my video, I would like to incorporate this video with on the next lessons. I will explain how we do it on the board of my teaching video, like on the previous video. But it will be at least a few lesson, a few my teaching video to show you the performance like of our computation and the iteration technique um, to find the volumes of solid revolution. So thank you for watching, and I hope you enjoy my presentation today. See you in the next video for the lesson. Stay tuned for the next interesting lesson about this topic. Thank you for watching and bye for now.